differentiate. 4/3 pi r cubed. The variable here is r. What this would be is the derivative of y with respect to r, because the variable is r. Whatever this variable is here is what appears down here. I normally would just say y prime, but the variables are. So it's the constant times the derivative of r cubed. Now if I would have said d dx, then suddenly r is not a variable anymore, because that says the variable in the problem is x. And this guy has no x's. He would be treated like he were a constant. Well, you'll learn that in 218. So what is this? This is 4/3 pi times, what's the derivative of r cubed? 3 r squared, yeah. So 4/3 times 3 is just 4 pi r squared. And I'm going to rewrite this as y prime because I like him better, because we started out with y. Now this guy's tricky. Now because they have numbers beside them, by the way, that comes from your textbook. So these are even problems in your textbook. Now if you notice, 2 has an exponent of 1, 3 has an exponent of 1. They're positive exponents. I can't use power rule with this guy down here in the denominator. I'm going to have to rewrite him as 3 over 2 times 1 over r squared which is 3 over 2 r to what power? Negative 2. Now I have a problem I can differentiate. I can use power rule on him. So that y prime is 3/2 times, what's the derivative of r to the negative 2? Negative 2 r to the negative 3, yep. Now, negative 2 over 1 times 3 over 2 is going to be just negative 3 r to the negative 3. Just leave him that way until you know what you're going to need to do with him. Any questions? Now, this is something that turned up last hour that a lot of people had problems with, and that it's converting radicals. If I have the nth root of a to the m power, I need to have two different things. If I want to rewrite him without the radical, it's a to the power on the radicand is the numerator, the power on the index is the denominator. It's a to the m divided by n. It's a fractional exponent. So what goes in the denominator is the index on the radical. What goes in the numerator is the power on the variable. So for example, the 4th root of x cubed would be the same as x to the power is 3, the index is 4, will be x to the 3/4. And you're going to do a lot of that. So here we go. I need to rewrite this. F of t equals, this is 2 times, this is the square root of t cubed. So the index is 2. This would be t to what power? 3/2 plus 4 over t to the 1/2, because that's square root of t, and minus square root of 2. Square root of 2 is just a constant. It's 0.14, or 1.14 approximately. It's just a constant. I'm still not there, so f of t equals 2t to the 3/2 plus, I need to bring the t to the 1/2 up. This is 4t to what power? Negative 1/2 minus the square root of 2. So in order to work with radicals, very often that's what you're going to end up having to do. Now, f prime of t, the variable is t. So it's 2 times the derivative with respect to t, because the variable is t, of t to the 3/2 plus 4 times the derivative with respect to t of t to the negative 1/2 minus the derivative with respect to t of the square root of 2. This is 2 times, what's the derivative of t to the 3/2? 3/2 t, and this is what you need to get used to. It's the 3/2 minus 1 plus 4 times, now what's the derivative of t to the 1/2? Negative 1/2. Negative 1/2 t to the 1/2 minus 1 minus, it's a negative 1/2 minus 1, and what's the derivative of the square root of 2? 0, because he's a constant. Now, when I'm dealing with things like this, 3/2 minus 1, that's the same as 3/2 minus 1 is 2/2. I pick it up and make the 1 what that denominator is. If that were 3, I would make it 3/3, because 3/2 minus 2/2 is 1/2. And if I'm looking at negative 1/2 minus 1, it's negative 1/2 minus 1 is 2/2. So this is going to be a negative 3/2. So those you'll be able to do in your head after a while. So 2 times 3/2 is just 3. T, 3/2 minus 2/2 is 1/2. Minus, because I'm going to take 4 times negative 1/2, is 2t. Minus 1/2 minus 2/2 is minus 3/2. You'll get used to it. You just have to work a lot of problems. And the one thing that I have to say is this. This is about the third of the course. It's differential calculus is what this is called. The next piece of the course, which starts in chapter 5, I do believe, is integral calculus. We call that the antiderivative. So then you're going to be given a derivative and work your way backwards. It's like FOILing versus factoring. FOILing's the forward process, factoring's the backward process. FOILing is the derivative, anti-FOILing is the antiderivative. Which means the better you can differentiate, the better you can anti-differentiate. I learned that as a student. You can rarely, if ever, get me on a derivative. You give me something, I can differentiate it. No problem. You give me an antiderivative, you can stump me sometimes on an antiderivative. It's just like factoring. No matter how good you can factor, somebody can give you something and you can get stumped for a while until you figure it out. How that sucker factors, if it, knowing that it does. So, the better you are on the stuff we're doing now, the better it's going to be for you down the road. I used to, when I was at the University of Illinois, I took my first semester algebra at Anne Arundel Community College in Arnold, Maryland, and that's where I took Calc 1 and Calc 2. And then Calc 3, we moved to Illinois, so I took Calc 3 at the University of Illinois. I had a teaching assistant, poor little thing. And it would be that, I could differentiate anything that moved. But he also knew if I raised my hand on a question for an antiderivative, if I couldn't get it, that means he was going to have to do some work. And he used to cringe every time I'd raise my hand. I had so much fun. It's like, oh no, she's going to ask a question. Not her, anybody but her. But that was fun. See, that's how you can torment me. You can be so good that I know if you ask me a question, I'm going to have a heck of a time with it. I challenge you to do that. Okay, we don't have any other rules yet, so this says multiply first. That means this guy needs some algebra. So I'm just going to multiply through the x squared, so this becomes y equals x squared times x cubed is x to the fifth minus 6x squared times x is x cubed plus 7 times x squared is 7x squared. Now it's just power rule. Before, we're not sure what to do with it. Now it's just power rule. So that y prime is 5 times the derivative with respect to x of, sorry about that. You see what I did? I started the process already. My bad. It's just derivative with respect to x of x to the fifth minus 6 times the derivative with respect to x of x cubed plus 7 times the derivative with respect to x of x squared. I use dx because the variable in the problem is x. The derivative of x to the fifth is what? 5x to the fourth minus 6 times the derivative of x cubed is 3x squared plus 7 times the derivative of x squared is 2x. So that y prime is 5x to the fourth minus 18x squared plus 14x.